Taking a look at two more examples on this factor by grouping, which, as I said, remember, 4 terms. So you need the 4 terms to be in order to be able to use this method. So let's take a look at our example here. 1, 2, 3, 4. We do have 4 terms in our polynomial, so we can go ahead with this method. And we also need to take a look at our exponents, the degrees, if you will, of each of our terms. X cubed, x squared, x, and then a constant. So this is what we would call descending order. The exponents are decreasing or getting smaller as we go from left to right. So we are good to go. Now our job is to take each one of these terms and put it in one of the squares of the box. So starting with our 16x cubed, that's going to sit in this first box here. And then our constant term, the negative 21, is going to sit in this box down here in the right-hand corner. These two we can put in either box. I'm going to put in negative 28x squared, and then the 12x I'm going to put down here. Now we proceed with our 4 factors. We're going to look for the greatest common factor. I'm changing color just because I'm bored. And we're going to factor going down each column, 1, 2, and then across 3, 4 in each row. So starting with our first column here, when we look at our numbers, our coefficients, we have 16 and 12. The greatest common factor between 16 and 12 is going to be the 4. Now, notice, 2 is also a factor of 16 and 12, but we want the greatest or the biggest common factor. Now taking a look at our variable of x, we have x cubed and we have x, so our greatest common factor would be that x there. Looking at this column here, we have 28 and 21. Greatest common factor between 28 and 21 would be 7. And then looking at our variable, we have an x squared in this box. We do not have any variable x in this box, so the greatest common factor will just be 7. Now, in regards to the sign that we need in between this 4x plus 7, we look to the closest box to the factor of 7. 28 is negative, so we put a negative sign in our factor. Now take a look at the greatest common factor in this row here, 16 and 28. Again, we have a greatest common factor of 2, but we want the largest that we can get, and in this case 16 and 28, the largest factor, the greatest common factor, is going to be 4. Now when we take a look at our variable x, we have x cubed and x squared, so we have x in common, but this time it's x squared, not the plain x or the linear x like in this factorization. And last but not least, in this row here, we have 12x and we have 21. Factor in common between 12 and 21 would be 3. And that's also, it's the greatest, but also it's the only common factor other than 1. And taking a look at the variable, we have x and then there's no x. So the greatest common factor for that row would just be 3. We look to the closest box, the 12, it's positive, so our 3 is positive. So our factoring would be 4x minus 7, 4x squared plus 3. And as usual, you would want to FOIL this to check to make sure that your answer is correct. Last example here. Again, 1, 2, 3, 4 terms. And let's take a look at the exponents. M squared. Here we have m to the first. I can put that in. N to the first. So these both have powers of 1, which makes the power or the degree of this term 2. So 2, 2, this m is to the first and this n is to the first, so we are indeed going down. 2, 2, 1, 1. So it's in descending order, and we can put it in the boxes. 6m squared minus 5mn minus 6m, and last but not least our 5n. Again, we're going to factor. Going down in this first column, 6m squared and 6m, we can see that we have the coefficient 6 in common, m squared and m, we have that variable m in common. This column here, 5mn, 5n, 5, the coefficient 5 is in common, and then we can see that we have an m here, no m here, but we do have n and n here, so we can identify a greatest common factor as n. Looking for the plus or minus sign we need inside our factor. Look to the closest box. It's negative 5m, so that would be negative 5. Continuing on, we're going to look at the factor of this row here. 6, coefficient 6 and 5. There's nothing in common other than that 1. I'm not going to write it, but if you wanted to, you certainly could. Now looking at our variables, m squared and mn, m squared m, we do indeed have an m in common. There is no n here, so it would just be the m. That would be our factor. In this row down here, the bottom row here, we have a 6 and a 5. So again, in terms of our coefficients, the only thing that's in common is our 1. Looking at our variables, we have m and n, so there's no variable in common. So it looks like there's nothing in common, but remember, 1 is always a common factor, a very important one, so we need to write 1 as the common factor there. Looking at the sign that we need in between here, we look to the closest box, so it is a negative. So our final answer would be 6m minus 5n, m minus 1.